We will have our first tutorial, and the speaker is Dr. Aneesha Bakharia. And Aneesha is currently employed at the University of Queensland, and she is a senior lecturer in the School of Electronic Engineering and Computer Science. And Aneesha really has a rich and diverse experience in her career. And she began her journey as an electronic engineer before pivoting to a career in educational software engineering and development. Her diverse experience spanned across the higher education and the vocational education sectors, where she has excelled in various technical innovation, project management, and learning analytics roles. And besides all these contributions and experience, she has written live books on programming and web development, sharing her knowledge and passion with a wider audience. Yeah, what a fantastic career. And next, I will hand over the microphone to Aneesha, and so that Aneesha can navigate us through the tutorial about generative AI. Yeah.
Thank you so much. Thank you for that wonderful intro. I'm really happy to be here today. So I do have a little bit of a diverse background, and I'm actually going to try and share some really practical tips for using generative AI, particularly within data analytics. So for me, I would say when I did my PhD, I found the PhD school to be of great benefit to me. So particularly, there was one speaker that, just coming here today, I actually think of. And the best advice he gave me was, in your first year, do something. In your second year, you probably won't be doing much. You will explore different areas. But in your third year of your PhD, you really need to get your act together and pull everything together. And I kind of took that away with me. And I think my PhD landed up going along those lines. So I'm here really to talk about generative AI, large language models. Is it okay?
You can keep
Yep,
going.
okay.
Adjusting the last.
So I've got 45 minutes, and what I really wanted to take you through is a couple of things. So the first really is just want to give you a very high-level overview of some of the current capabilities of large language models, and particularly how that relates to data analysis. I then have two really practical tasks. So I thought about, what could be the most practical task that I wanted to give you that will work within the time frame, but also give you exposure to some of the capabilities, but also highlight some of the issues when working with these large language models. And the two things that really came to mind for me was, yes, data is important, and what you're basically either going to be doing is trying to get ChatGPT to help you write data analysis code. But what are some of the gotchas with doing that? So the first task is all about that. The second task really is taking note of the fact that you're all researchers. Some of you are going to be building algorithms. Others of you are going to probably have a set of data analysis scripts. And how do you actually take that out to the world? Share that with participants in your research studies. Actually, maybe you have a final product that you might want to commercialize. So how can you actually start to think about not just having code that's standalone that you can run, but how can you take that out into a product that's got a user interface that you can actually deploy? So task 2 is along those lines. I also want to share some prompting tips with you. The good news there is that just about every week almost, prompting becomes easier because these models increase their capabilities. But finally, and I think this is the really important bit that I wanted to stress today, is you're not just doing data analysis, and you're not particularly what I would class as, the core data science type group, because you're also trying to take things that step further. You're really looking at information resilience. And so this deeper thinking for your actual research is, what does all of this generative AI actually mean for information resilience research? And what are the ways that I can contribute to it? And then finally, we'll just look at some current trends, which mainly revolve around agent-based systems. So let's get started. Probably trying not to make my intro go for too long. But one of the things really early on, so I would say, if we look at, the 30th of November, 2022, we're just basically under a month away from ChatGPT actually turning 2 years old. And you think about how much progress has been made in those particular 2 years. But really early on, I would say around about March 2023 in the piece, what people started to see was that it wasn't just that it could generate programming code or write essays for us or answer questions, but I was actually starting to see papers emerge really early that were actually looking at just different types of data analysis and different steps in data science type workflows that people were starting to use large language models for. So this paper was released really early on and then only got published this year. But it really showed just different steps. So everything from cleaning data to building models. You could actually get a large language model to generate the code and do some of that heavy lifting for you. I think there were other papers, that were really asking, not only from the education side about what we should be teaching students, but also what does this all actually mean? And that was happening across a number of different domains. And I like to showcase some of the capabilities of these large language models through my presentations. And so what I always try to do is, okay, to what extent has, to what extent are data scientists, data analysts actually starting to use large language models? And a good way to actually gauge that is to just look at posts, whether it's blog posts or, other publications, where they actually have, these are the top 10 data science prompts that I'm using. These are the top 50. These are the top 100. And there's a number of blog posts like that are out there at the moment in data sciences. And here, what I'm basically doing is using ChatGPT and basically just giving it those links and asking it to, can you go and summarize these for me? So note, these are just links. It's going to use some of its capability to go and search the web and actually pull in that data. And then I've asked it to give that back to me in a table, but not that I really trust it, but give me some examples, or give me one example of just some of the prompts that were included inside here. And you can see quite a broad depth of things, from being able to write the Python code to create your machine learning models, deep learning neural networks, some data wrangling type things, even trying to get it to do some things as act as a data bias expert inside there. So really broad and really diverse inside there. But I include this just to give you some sort of understanding and appreciation for the range of tasks that people are actually using large language models for. So the real game changer here, I think, might have come about April last year, with a product from OpenAI. And at the time, I actually saved this blog post by Ethan Mollick, and he's a professor from a university in the US, and he publishes or writes a lot about using large language models across the board with a range of diverse tasks. So I think he's always in beta programs and he's always testing things out. But I saved this blog post because I looked at it quite amazed. And also that I wasn't on the beta program and I didn't have access at the time, but this is the first time I saw where it wasn't just getting the large language model to generate the code, which the user would then take and run somewhere else. This was getting the large language model to write the code, run the code, and produce some visualizations inside. So it was doing a number of things. And when you look at this, there's a few things that should be screaming out to you right now. The first I would think is, this is really amazing. What about data privacy? Because you're actually uploading a data set and it's able to do this, right? The second thing here is this really reduces the barrier of entry, because now you don't even need to be able to run that code. And by run the code, I mean you don't need to have anything installed locally. Just need to put your data set, upload it, and then you'll be able to do this and interpret it. Now, what I hope from you at this particular moment is to start thinking and put your data resilience hats on and think about all the things that this enables, but all the things that could possibly go wrong with this. The next thing that I'm going to show you, so this is all still in my intro, and I hope not to be talking too much because I do want to get you to do some practical tasks, as I mentioned. But what I do want you to understand is a little bit of the capability. So around about last year, I think almost exactly to this particular week, it was the OpenAI Dev Day, and they released something called a custom GPT. This basically just meant I could write a custom prompt, and I could also tell it that it could use tools. And so tools you could think of as different libraries. It supports Python, and of course Python has this really rich data science ecosystem. And I think maybe the second thing that I made with custom GPTs, the first was a design thinking custom GPT. The second GPT that I made, I called Data Analysis Hero. So this is still live on the custom GPT store. And I almost think, oh my God, did I try to do too much? And what are the implications of me actually trying to do too much with this particular prompt? So it tries to take that ability for a large language model to actually run code, but it tries to take that a few steps higher. So it's trying to get it to actually interpret data. It's trying to go from an uploaded file without any user input and actually generate a report. So it's going to generate images, it's going to take them from the file system, put them into a Word document, give them headings, and then try to describe what is actually in each of those particular charts inside there. And, how long would this prompt actually be? In essence, it's just a couple of lines. So the first thing you're going to notice is I'm giving it instructions on what to do, but my instructions are really fuzzy. You think about if you had to program this in code, okay? And so this is one of the capabilities in these large language models, that we can just write in English and they can understand us pretty well. The other key thing here is, okay, I'm getting it to do data analysis. I haven't had to be very specific about the technology it has to use because inherently it knows it has access to Python and a range of Python libraries. So basically tell it, analyze the data set, find the key insights, create the visualizations, put them together in a fact sheet, but then not only taking note of the fact that it actually has the ability to actually run that code, every library that's installed in its virtual machine, you can think of as an actual tool, right? And one of those libraries creates Word documents. And so it did struggle to get the structure of putting in those pictures. And this is where I found that I could use a code snippet and actually teach it how to do it. So initially, it would error out, so it would do everything else, but in terms of being able to pull out the document and put the images it generated in for the visualization, it was crashing. And it was looping itself trying to fix it. And then I realized, okay, well, why don't I just put that particular code snippet and tell it to use that particular code snippet when it needs to put the document together. And then also make that, now it's using one of its tools, is that generate the document, let the user download that document. So this was my first kind of big experiment with fuzzy instructions, doing a lot of things. And I think it works to the extent of it actually doing the tasks, right? So it goes ahead, looks at the data set I've uploaded, generates some code for it, generates a series of charts. You can actually click the little links at the bottom there to actually see the code it was generating. And then, of course, you can get a file to download. And this is in a Word document. It's followed my instructions for creating headings and being able to insert this. And then it's obviously trying to interpret and use some of its vision processing to work out how it would actually describe this. Now, perhaps when I think about this, I had the ability to take this and straight away just click a button and release it into their particular custom GPT store. What are the implications here? Like, I have not extensively tested the capabilities, so I know it can execute code and generate charts. But the key thing here is, did I really validate that it can do interpretation of charts? Or that these particular set of visualizations it was creating were the best way to visualize the data? What about data cleaning? Do I know how it has cleaned the data? Or is that appropriate? Or did it miss specific things inside there? So we'll end up in the situation where we've got capabilities to do all these new things, but we also, me particularly, I'll end up with a few doubts in going, yes, it's got all these capabilities, but if I were to take this out and put this into an organization, what would I then need to be thinking about? And how can I put some safeguards on top of this to this level? So with that in mind, and that was really just to give you a feel of capabilities that currently exist, I actually now have 2 practical tasks that I would like you to do. So let's do one at a time. So the first one is to try and get you to generate some code to perform some analysis. All right? I've chosen a really simple data set. It's from last year, and it's the data science salaries data set. I've got a link there where that'll let you download it really fast. It's also from Kaggle. I'd like you to use any generative AI tool that you're familiar with or you have access to. Whichever one you're using doesn't really matter particularly. They all have different strengths. Some work better than the others. Some are paid, some are free. Choose what you've been using. So you could use ChatGPT, you could use an Anthropic Claude, you could use Google's Gemini, or the Gemini that's even built in a Google Colab notebook. Hugging Face also have a lot of free data sets, and they also have a chat user interface that actually links into a lot of the open source models. So if you wanted to explore those, go ahead. And then I've got a seemingly simple task for you to do today, which is just to calculate the average salary of employees from that particular data set. I'm not giving you any information about the columns. There is some information on the web via the Kaggle link. But ideally, just take the data set and see if you can create a prompt to actually compute the average salary for employees with senior level expertise above intermediate. Okay? The one rule here is that when you generate this code, so if you are using something that's able to execute the code all in one, that's fine. If you're using any other models that don't generate the code, try to run the code yourself. And a great way to do that is to use a Google Colab notebook. So I'll leave you with that task. I will walk around and see if anybody's got any questions, even just about running a Google Colab notebook. Jupyter notebooks are also great for this task. There are a few gotchas with this task. So it is seemingly simple, but there are a few gotchas with this task. So I will let you go through and do that for the next 10 minutes. Great, I'm seeing a lot of people starting to use either ChatGPT or Claude and firing up a Jupyter Collab notebook. Okay, so I'm seeing some people have already got the answer, so you're either using ChatGPT and it had the inbuilt code interpreter. So if you do already have an answer and the code's been executed, try to think about where it could actually have gone wrong. Not that it did go wrong, but where could it have gone wrong, and how could you actually know? So how would you test and validate what is coming back with? It was really just trying to get you a feel for trying to generate some code and take a small data set. And I did try and choose some, one that perhaps wasn't that simple, or seemingly it was that simple. So you got a data set, it's got a couple of columns inside of it. It's not all that huge, so it's not going to break the upload limit on any of these large language models at the moment. But I'll share with you my prompt. And there's a few interesting things, right, to note from here. So I'm actually very specific. So I think I've seen a lot of the two popular models that I've seen just from walking around has been ChatGPT and the version that's probably paid subscription that has the code interpreter inside of it. And that's just showing the prevalence of that particular tool. The second was Claude Sonnet 3.5 being used. Now those two models, they're probably the expert coding models that are out there at the moment. So if you look at how I approach this, trying to get this to work in a few models. So I'm very specific about the fact that I might want to run this locally myself, and I have a specific technology platform that I use. So I'm very specific about using Python and Pandas as the libraries here. You could be doing R pretty much, and so you probably want to be specifying R code if you wanted the R code back for your particular project. So that's my first tip inside there. I am then very specific about the steps that I want this to perform. So I obviously have used some of my background knowledge, so I'm not coming into this task without knowing those steps. And I could also go very specific on what type of data cleaning that I wanted in here. But there is something else that I've not done here. Who knows what it is? So note, I'm using ChatGPT, which has the inbuilt code interpreter, but what have I not done?
In the metadata?
Sorry?
Metadata?
So I am putting in metadata, but my question is, what have I not done?
Try catch?
No? Exactly. Here we go. So here's the answer, right? If I had a data set that was from my organization, I might have ethical and privacy concerns about actually uploading that data into ChatGPT. That does not necessarily mean I can't get it to help me code. So what I've actually done here is I ask it to do things. I don't think I'm giving away anything by giving it the name of the file, and that just means I don't have to change it later. But I do something else here is now I start telling it which fields to perform the calculations on by their name. And that removes the necessity for me to upload the file. And then finally, the other catch, and this is a really big one about the sort of automated data analysis that it can do. I am very specific about translating the level of experience myself to exactly what those encoded fields are. So I did not want to leave that to chance. So it might know, and then might be able to put exactly into the filter what needs to go there. But when I reviewed the data set first, I didn't know what some of them meant, and I had to go and look up some more information about the data set, and then I can very specifically tell it to do that. So that obviously has taken away some of that ambiguity. Because if it got this wrong and you did not know it got this wrong, your analysis is going to be incorrect. So you can see how it can do all these things for us, but you still need to know a bit about your data set. You still need to be aware of your privacy and ethics. And if you do have the domain knowledge, what becomes important here is that I'm actually using it to do very specifically what I would have done and learnt about in data science to do that calculation. And so if it's the other way, where I just ask it to do the analysis, I then need to have the skills to go and check each of those steps to make sure that it did the right thing. So finally, of course, you do get a nice error from ChatGPT here. The main reason is because it actually thinks it has the data set. I haven't given it, I've given it some descriptions of the fields and what it needs to filter on, and it's actually then going, okay, I've written this code, I'm going to try and run it because I believe I have that data set. So it hasn't really picked up itself that it didn't, that I can give it to it. But you can see how I got around some of the privacy settings inside here. I got around preserving my data privacy, but still getting it to write code. And I think this whole ability of the semantic code, and it's not, you know, I need to be more specific about what I want to do, was something that you were discussing with me as well inside there. So I definitely agree with you, and I said my solution will be doing the same. Okay. So I'll come back to some basic prompting tips here. You see, I don't necessarily do a persona prompt anymore, so I'm not saying act as a data scientist. The models have gotten much better that we don't need to do that. Sometimes I do use think in steps to kind of elicit some reasoning, but also I'm finding that less and less I need to actually do that. What does become important is the domain knowledge. So what language do I want it to generate the code in? What libraries does it need to use? What steps would be the best for this particular data set? So what type of data cleaning do I need to do? Oh, and then finally, you really need to have this knowledge to go, okay, it's given me back this. I can't just take it and use it. How do I validate the data? How do I debug if something's wrong? And so that sort of core understanding still needs to actually be there. The second task, so I'll probably give you a few minutes to do this one. So I've probably just got 10 minutes, but let's do this task for about 7 minutes, and then I'll try and tie it all together. So now imagine you've done some great research. You've either made a new algorithm or you've got a sequence of data cleansing steps that work really well, and you want to deploy this. The next thing that you can do with these large language models is actually build data products. So again, this task here is, can you build an interactive radio dashboard? And now I'm really putting on the constraint because I'm only going to give you 5 minutes to do this. So for this one, I've actually given some hints. I was trying to make things that weren't, you had to actually prompt, but for this one I'm actually giving you want to use something called Radio, which is a little, it's a library that is able to build graphical user interfaces. I want you to use the charting library called Plotly, and you need to basically be able to filter by company size and then view the average salary by experience level. So this one obviously is a tricky one, and I'm really trying to push you here to make the best of what you can get from your large language model and then run that in Google Colab. So, all right, if I give you maybe 4 minutes now, let's see if anybody can actually get that UI built. Okay, so we've got one person that was able to succeed at that task. We've got one person that got some code back and ran it and came back with an error. Yeah, okay. We've got another person that's got it up and running just in a Jupyter notebook. Excellent. Okay, so that to me is quite amazing that we already have a couple of people. Sorry, we've got a little bit of a time constraint today. I think with another couple of minutes, a lot more people would be able to get that up and running. So I'll share my prompt. Basically, again, very specifically here, I'm asking for a set of libraries And I asked for those set of libraries because I know that I can actually run that in a notebook environment and actually have the user interface display. And I also know that this particular library, Gradio, you can actually deploy it. So you can have your users actually use it. You can see I go very specifically again into the fields that must be used and how to do that, and I get back some code. Now, like the PhD student over here, when I tried to run it, I got an error. I also got an error. And the reason is because some of these libraries change faster than these models update. So there's usually like a couple of months span and the time period that these models are run to. But all I basically do, and sometimes it'll generate an error, you give it the error message, and then it does know and have that knowledge. It might not have been the majority of documents that were using the new features in the library. So it then gives me a new set of code. So you can see how I'm even getting the large language model to do some of the debugging and help me do that. And then basically I was able to get the charts as well. So I'll show you what that looked like for me inside here. So that was my task 1. This was my task 2. A lot of people figured out that you had to do the installation as well, but my version of the large language model didn't tell me to do it, and I actually had to ask a question. And here's the code for Gradio to do that, designed the user interface, worked out the drop-down, worked out what to put inside the drop-down, and then it worked out how to do the chart for me in there as well. So we've got this great capability, and I'm probably going to try and wrap up in the next 3 minutes inside here. So we do have this great new capability, right? And you really then have to step above this and think about what do we need going forward? And so what sort of AI literacies do we really need? The key things for me still revolve around, we still need our domain knowledge. It's faster for us to generate code and it's faster for us to iterate, but we need to know what we're doing and why we're doing it. And we need to be able to interpret what's coming back, validate, test, and debug it. So I see a lot of progress being made in these large language models, but for us to safely and ethically deploy these tools within our organizations, we're still going to need all of these skills. And there's a few more things. So we need to know when they fail. So they can hallucinate. How can we prompt to avoid that? So me specifying specifically what experienced was in terms of the acronyms was partly my way of saying I don't want it to hallucinate. I want to be very specific so it does not hallucinate. So we can prompt our way, but we need to know the risks, so the bias in the models, that they can be tricked with prompt injection. And so when I put this up here, this is everything that we need to know, or that I think we need to know going forward. And of course, it's not all about you as a researcher, particularly within the field that you work, using it to help you do data analysis, using it to help you generate code. Yes, it can be very good at that, but there's a whole lot of these other implications that it's going to give us. So my very first, or my second example that I showed you of my custom GPT, Data Analysis Hero, it takes advantage of a lot of capabilities, but it introduces a number of risks where it tries to do so much, but it could get anything at any time wrong, and in different runs of it across the same data, it'll always produce different charts and results. So if you think about all of these generative AI tools being incorporated into data pipelines at the moment, there is a huge amount of scope for actual research and trying to do safeguards across it. If you think about everything previously where humans were making errors, you now think of the human errors plus the large language model errors being incorporated into all of this. So how can we take advantage of this and prevent that from happening? And I guess the final thing that I would include here basically is, it was a very interesting paper. The tool is called Indict, and it tries to mine previous exploits that have occurred in a particular domain, and then tries to get another language model to actually start looking at the results that come back and propose and ask things as well. So this is where we're not just using one large language model, we're getting them to play different roles. And if we're able to get data sets that actually encapsulate a number of the errors, so data cleaning errors, data processing errors that occur, we can actually start putting these into our pipelines as well. And this was just to get you to trigger your thinking about where you could potentially head. And the final slide here, if we take that idea of multiple language models, a lot that's been happening since last year and continues to this day is building systems of large language models. So this is not where you got one or two, it's many of them that you're orchestrating to actually do tasks. So I'm seeing this in data processing pipelines, even coming from AWS at the moment, where they're using the large language model to help generate SQL that actually then runs inside a database, gets data back, gets validated, and they're using different roles of the large language model inside there. This is where I think it's all headed. It's getting these large language models to do smaller tasks and then being able to validate that instead of larger tasks. But it's that whole orchestration level. I do also see this as a key skill that you will need going forward inside there. So with that, I've reached the end of this tutorial. I hope that's given you key insights on some of the capabilities and also some of the things that you really need to think about.